Hi, everyone. Just let me know real quick in the chat if you can hear and see me okay. Awesome. Hi, well, my name is Jenny G. Ross, and I am an AP Calculus teacher from Grafton High School, which is in Central Massachusetts. And today we're going to talk about the chain rule. So a couple things we're going to talk about is, first of all, what is a composite function? And how can we find the derivative of a composite function? We're also going to define the chain rule. We're going to use the chain rule to find the derivative of functions, including polynomials, trig functions, and also some products and quotients in there. So if you haven't talked about products and quotients, we'll review that a little bit as well when we get to that part. And then, of course, we're going to practice interpreting our results as well. So the first thing I want to talk about is, let's go back to the very basics and say I want to find the derivative of a function similar to 2x plus 3 squared. So hopefully at this point you know a few what we call one steps, some derivatives that we just know, right? We memorize the derivative of them. But if you look at this function, it's not quite any of those, because there's the something squared, which we could take the derivative of x squared, we could do that, but there's also this 2x plus 3 in there that's going to cause us a little bit of problem. So that's where this chain rule is going to come in. So the first thing I actually want to do is I want to take this derivative the hard way, right? Because we can always use more practice with the limit definition of a derivative because it's a little tedious, but it gets us the answer. So we're going to do the limit definition of the derivative here to find the derivative of this, and then hopefully we'll talk about how we can get a shortcut out of this. So if you want to kind of do it along with me, feel free to go run, grab some paper, we can write it down, or you can just watch. Okay, so remember the limit definition of derivative, basically says that I want to take the limit as h approaches 0. And then we're going to do f of x plus h. So we're going to take that function, and instead of x, we're going to write x plus h. And then we're going to subtract f of x. And all over h. So again, that's just a fancy form of the slope formula, right? When we did change in y over change in x, and so that top is our fancy change in y, two functions that are h units apart, and our bottom is our change in x, h units apart. So now this is going to get a little tedious. So in order to kind of figure this out, we have to do some multiplying everything out here. So I'm going to go through it with you. Feel free to work ahead or stay with me. So I'm going to quickly just distribute out that 2. And I'm not going to go too quick because that's where we make mistakes, right? Students and teachers. So I'm going to take my time here. Next thing I might want to do is start squaring those things. So that's going to get a little messy. So I'm going to do it off to the side here. I'm just going to move that over for just a minute. And I'm going to do 2x plus 2h plus 3 times 2x plus 2h plus 3. Just so I can kind of see it as I do it, right? So the first thing we're going to do is take that 2x, and we're going to distribute it to all 3 parts. That's going to get us we've got 2x times 2x. (2x plus 2h) and 2x plus 3 times 3. And then the next thing we're going to do is take that 2h and distribute it. So that actually gets us 4xh plus 4h squared plus 6h. And then lastly, we're going to take the 3 and distribute it. All right, so I'm just going to give everybody a second because I know listening and writing is hard. So go ahead and take a second to copy that all down if you need to. All right, so we still, unfortunately, are not done with that line, right? Because that numerator also needs a minus 2x plus 3 squared. So we now have to do 2x plus 3 squared, which luckily is a little bit faster. So we're going to subtract that. So we get 4x squared plus 6x plus 6x plus 9. All right, so this is when my students start complaining. It's taking up the whole piece of paper, and it totally is, right? But now what we want to do is see what happened. Did we get anything that can cancel? Usually we do, right? So that's the fun part of this experience is getting it to cancel. You may want to kind of quickly rewrite this here. I'm not even going to bother rewriting the whole line because it's long, okay? But I can just simplify that part a little real quick. So now I want to start canceling things out. So hopefully, realize I made a little mistake there. You start seeing things that cancel. So we got a 4x squared here. That cancels with the 4x squared there. Or here. And then what else do we have that cancels? We have a plus 6x that cancels and a minus 6. Plus 6x here and a plus 6x here. That cancel with the 2 plus 6x's inside. Or the 12x. We also have a plus 9 and a minus 9. All right, so we canceled a whole bunch of stuff. I think that's all that we can cancel. So let's see what we have left. We have the limit as h approaches 0. We have 2xh here and 4xh there. Plus 4h squared. And then we have 6h and 6h. And then here. The next thing we want to do is we want to get those h's to cancel. So I didn't say it earlier, and I totally should have. The first thing that we usually do when we do a limit, right, is we plug in h is 0. If you did that, you would have gotten 0 over 0, which means do more work. So that's why we did all of that work, right? Because our goal is to try to get it so it's not 0 over 0 anymore. It's still 0 over 0 if I plug in 0 here. So I'm going to have to now try to get rid of some of those h's so I don't get a 0 anymore. So I might factor out 6x. And our h's cancel. And we plug in h equals 0 now, and that 4h in the middle cancels, and we get, looks like a 72, 6x plus 12. And that was a lot of work. So all of you are saying, please don't make me ever do that again. Give me the shortcut, right? That's what we're going to work on now. So how can we find the derivative of that function without having to do all of that work? Nobody wants to do that work. So let's talk about the shortcuts that we do have. At this point, as long as you've started learning about derivatives, you probably went through the process of developing a power rule, right? So you probably talked about the derivative of x to the n, and you established that that was n times x to the n minus 1, right? So you've established that rule already. And our function looks a little bit like that. It has something to do with an x, and it has a power. So let's see if we can apply the power rule. So if I take the power rule here, my power is 2. So I'm going to bring that 2 out front. And then I'm going to get some parentheses here. And for now, I'm just going to leave that 2x plus 3 because I don't really know what to do with it yet, right? And the power n minus 1 goes to 1, which means I get 4x plus 6 as my answer there. Sorry, I'm just looking really quick because I think I made a little mistake here somewhere. Now I gotta find it. Let's go back to this real quick and see if I can find my mistake. Let me know if you saw it as we go. I think it has to do with this part right here. Where did that come from? Oh yeah, that should be a 4, right? So whoops. Hey guys, feel free. We all make mistakes. If you see it as I go, just give me a stop. So I multiplied wrong there. That should have been a 4xh right there, which then I followed that mistake down all the way. So I should have gotten 8x here. Now this won't go away. So that was a little distributing error. You're right, Kevin. Thank you. When I multiplied the 2x times the 2h, I wrote 2xh instead of 4xh. So that mistake started right here, and then it continued here, right? This should have been an 8x. Same here. And we would have gotten an 8x. So that's a bummer because the whole point of this was to make the things match. But we know the answer now that I fixed my error. It's supposed to be 8x plus 12. So let's look at what we got here. Okay, we got 4x plus 6. And our answer is supposed to be 8x plus 12. Which, as you can see, is close, right? It's pretty close. So now we got to try to figure out where that missing piece came from, right? How do I get from 4x plus 6 to 8x plus 12? We have to multiply by 2. So where did that 2 come from? The 2 comes from this inside function, which a minute ago I just said, well, we're just going to write it down, right, and hope for the best. When we have an inside function, this is called a composite function, right? It's a function of a function. When we do that, we also have to consider what the derivative of the inside function is. So that 2x plus 3 has a role in our derivative, and we need to take the derivative of that too. So if we took the derivative of that, we would get 2, and when we multiply that, that would get our 8x plus 12. So I want to formalize that a little bit because I kind of said that fast. So let's say we have a function, we'll call it big F of x, and it's equal to f of another function, right? There's an inside function g of x, and there's an outside function f. When I take the derivative of that, basically what you're going to do is you're going to take the derivative of the outside function, so f prime. You're going to copy the inside function. So the inside function stays the same for that part. Whatever it was in the original function, it's going to stay that in the derivative. But then the new part is you have to multiply by the derivative of the inside function. That's what we call the chain rule. So derivative of the outside copy the inside into the whole, and then take the derivative of the inside. That's actually a pretty simple process. So let's try it with an example. So find f prime of x if f of x equals the square root of f 4x minus 3. So the first thing that you want to do is you want to identify what's the outside function and what's the inside function, okay? So sometimes we like to give you ones where it looks a little bit different. So, we try to mess with you a little bit, but this is very simple. The outside function is that square root. We don't know really how to take a square root function derivative either, but we do know how to do a power function, and roots and powers are the same thing. So I'm just going to change this. Good. 4x minus 3 to the 1/2 power. Because then I'm going to know how to take the derivative. I know how to take the derivative of something to the 1/2 power. So if I look at it this way, I now can identify that my outside function is something to the 1/2. I like to use the word something and write in parentheses because when I'm talking about the outside, I don't yet care about the inside. So I'm going to take that derivative by just saying I want something to the 1/2 power. And then my inside is going to be the something, right? What is inside? 4x minus 3. So now when I take the derivative, I'm going to start with the derivative of the outside. So my outside function is something to the 1/2. So its derivative, I'm going to bring the 1/2 down. It's a power rule. 1/2 times something. I'm going to subtract 1 from my exponent. I'm still using that derivative of x to the n. Equals n, right? You bring down the power, x to the n minus 1. So what I established here is the derivative of the outside. 1/2 got brought out front. I've got my something, my parentheses there, -1. That's step 1, derivative of the outside. Step 2, copy the inside. So we're going to take that inside function and we're going to copy it right into that parenthesis. Step 3, derivative of the inside. So now I look at the inside and I say, what's the derivative of that? The derivative of that is 4. So now we have our derivative. That's it. That's the whole chain rule. Step 1, derivative of the outside. Step 2, copy the inside. Step 3, multiply by the derivative of the inside. You can clean that up for sure. If this was multiple choice, right, we would want to clean that up and write it as 2, 4x minus 3 to the -1/2. We could change it to 2 over the square root of 4x minus 3. Lots of different forms we could leave it in. If it was free response, leave it right here, right? You don't need to simplify anything. And then you don't have to risk making a silly mistake like we all do, right? But certainly that -1/2 would move to the bottom if we were cleaning it up for multiple choice. All right. So I'm going to try another one. I'm going to actually let you guys play with this a little bit too. So first, before I let you play, let's just review the derivative of some trig functions, just in case we haven't seen that. So I like to call them one-steps. I don't know what your teachers call them, but basically what I say, it's one step. That means it's something that you just know the derivative of, right? So it's something you've memorized. It takes one step because you know it. So one of the one steps is the derivative of sine x. And you kind of have to memorize that. You might have proved it in class. Usually I do, but that's not the point of this exercise. So the derivative of sine x is cosine x. So that's a one step that you need to know for this problem. So I'm going to kind of talk you through it, but I want you to see if you can do it yourself before I write it down. So step number 1 that I want you to try on your paper or wherever you're taking notes, or in the chat is fine too if you can. I know it's hard without symbols. Step number 1 is take the derivative of, well, actually, let's start with what is the outside function. So why don't you tell me first, what's the outside function? Good. So I got somebody that said sine, somebody that said sine x. Those are right. I know in the chat it's hard. I'm going to tweak you just a little bit because, so the first person just said sine with nothing in it. We got to be a little bit more specific than that. Sine x isn't quite right either, right? Because it's sine of something. So I want you to write it as basically sine of something. Just because the thing that goes in is actually different than just x, right? So our outside is going to be sine of something, which would then make our inside 3x to the third minus 4x squared. So step number 1 is take the derivative of the outside function. So what would the derivative of sine something be? And I corrected the last people, so now nobody wants to answer. But answer, it's good. Good, perfect, Sierra. Cosine of something, or Kevin, cosine blank parentheses, right? So you got a cosine of something right there. Now step number 2, copy the inside. So we're going to take that inside function and we're just going to plop it right into that something hole we left there. And then step number 3 is take the derivative of the inside function. So our inside function, and we're going to multiply it together. So my inside function, 3x to the third. So you're going to take that power, you're going to bring it out front. So that 3 multiplies with the other 3, and we get 9x squared. That 2 moves out front, multiplies with the 4, and we get 8x to the first power. Perfect. Awesome, guys. And so this right here is our derivative. There's no real awesome format on how we would write that. Some people would move the 9x squared minus 8x to the front so that it doesn't, so that you can see the cosine input, right? So this right here is cosine of something, and then times 9x squared minus 8x. So sometimes that looks a little funky, so people put the 9x squared minus 8x first, but I don't know that it super matters. So we're going to try another one. So this one is a little bit tricky. I added one step here. So I want you to think about this for a second. What's your outside function? And be warned, it's a little tricky. Okay, so cosine squared is a good guess, right? But cosine squared is actually 2 different functions, right? It's squared and it's cosine. So we actually want to split those up. So that's why this one's tricky, because there's actually 3 pieces. Sierra is correct that the squared part is our outside part. So this is the same thing as saying cosine 5x squared minus 2. Take that whole thing and square it. So you actually have 3 layers of composite here. You have the squared, then you have the cosine inside of it, and then you have the 5x squared minus 2 inside of that. So this is going to be a 3-way chain rule. Okay, so that's a little bit of an extra step here, 3 ways. So we're going to start with the outside being something squared. And then the inside, for now, we're just going to say would be everything else, right? Cosine of 5x squared minus 2. So I'm going to start my derivative here. The derivative of something squared is 2 times something. I'm going to go ahead and copy that inside. And now I need to multiply by the derivative of the inside. So we did step 1, derivative of the outside. We did step 2, copy the inside. Our step 3 is take the derivative of the inside. Well, that's a little bit tricky because the inside is actually another chain rule. So I have cosine and I have 5x squared minus 2. So I'm going to actually have to break this into its own chain rule. So I now have cosine of something as my outside, and my inside is 5x squared minus 2. So now I'm going to start a brand new chain rule, and I'm going to put it in that line I drew. So this is kind of a strategy I use for more complicated problems. I basically say, I know I now need to do a whole different problem, so I'm going to leave a space for it because I know now that the answer to my new problem has to go in that space. That way I'm not still sitting there going, what step am I on and how is this working? I can just start a whole new problem and just remember, oh, I'm going to put it in that spot. So in step number 1, I did my 3 steps. I couldn't do step 3 yet, so I left a blank for it. Now I'm going to do that blank, right? I'm going to take the derivative of the outside. So the derivative, here's another 1 step for you, right? The derivative of cosine x is negative sine x. So the derivative of the outside is negative sine x. Oops, sorry. Need to copy the inside, getting ahead of myself here. Cosine of something is sine of something, negative sine of something. Copy the inside. And then we're going to multiply by the derivative of the inside function. So 5x squared minus 2. Bring that 2 down, we get 10x. The derivative of the minus 2 is just 0, so that goes away. And so we have our derivative there. Okay. Probably would want to clean this one up a little bit, especially if this was a multiple choice question. And depending on what your teacher's expectations for you are on an assessment, a lot of teachers do want you to clean it up. So you would probably multiply that 2 in the front by the 10x and get 20x. Negative, actually, right? Because we have a negative here too. So I can take that negative, the 10x, and the 2 and combine them together. The cosine and the sine doesn't really matter which one you put first. Usually you see sine first, but it really doesn't make any difference. And that's your derivative. All right, so here's another one for you. I'm actually going to give you a couple minutes because I want to see how far you can get on your own now that we've done a couple. So just a quick, in case you need it, the 1 steps that you need for this one, right? We've got the derivative of secant x is secant x tangent x. So that is a little bit hard to work with, right? You're going to have 2 somethings, secant something, tangent something. You've got to plug the inside into both places. The derivative of tangent x is secant squared x. So those are the 1 steps you need. So I'm actually going to pause for a minute and I'm going to give you like maybe 90 seconds or so to get started, and then I'm going to check in. And if you're stuck, then I'll give you some hints and then maybe give you a few more minutes to figure it out. So go ahead and work on that for just a second. Okay, so just doing a quick check-in to see where you are. So the very outside function should have been secant x. So secant something. And then the inside would have been tangent 2x to the fourth. So the derivative of secant something, so we wrote that right here, right? The derivative of secant something is secant something tangent something. So this part is a teeny bit confusing because you actually have two inputs, right? You went from secant x to secant x tangent x. So what you need to do is you need to input that inside in both places. So step one is derivative of the outside. Step two is copy the inside. So we're actually going to copy the inside twice. So you have secant of tangent of 2x to the fourth times tangent of 2x to the fourth. So that was step 1 and 2, right? Derivative of the outside, copy the inside. So our next step should be derivative of the inside. So I'm going to leave a hole for that because now our inside function has to split into an outside and an inside. So I'm going to give you another 30 seconds or so to see if you can finish off this problem now that I got you through the beginning. Right, so the outside now becomes tangent of something. The inside becomes 2x to the fourth. So now our derivative is secant squared of something. Copy the inside times the derivative of the inside. So again, that was a function inside of a function inside of a function. Usually they're only going to give you a function inside of a function. So this is actually even more complicated than you're often going to see, but this could come up, so we want to do a couple complicated ones. You can keep that chain going forever, actually. I could have 4 or 5 functions, and then I just, every time I get to the inside, I break it up again and do the same 3 steps over and over again. You leave the line, you do the 3 steps. Draw another line, do the 3 steps. So no matter how many functions I put in there, you can keep the process going. We could clean this up a little bit, not a whole lot. Usually we're going to put the 8x out front. That's really, I don't know, there's not very much we can clean up here, right? They're all just trig functions. The order doesn't really matter. Should it be 8x cubed? Yes, it should. Thank you. So we're going to move that 8x cubed, thank you, to the front. And then everything else just kind of tags along. I'm running out of room here. How long it is. The one nice thing I've seen about the AP test, at least, is that when they do, if they were to have a multiple choice like this, they probably wouldn't clean it up very much. They'd sort of leave it just because it is so long and complicated. But sometimes they do clean, especially if it's a little less complicated, they will clean it up. So you want to practice that for sure. But a lot of times, if it's super complicated, they'll sort of leave it in the predictable pattern. So you could see it either way. All right, let's try a product rule problem. Sorry, this is really small. It doesn't look that small on my screen, but kind of how it changes over the computer. Now I know, okay? So I'm gonna quickly review the product rule. So I don't know where you guys are. I know for us here in New England, we actually started school later. So we actually start school right at the end of August, beginning of September. So my students haven't even actually seen this stuff yet. So this is brand new to my students. It might be brand new to some of you. But I know some of you who are in other parts of the country have gotten this far already. So, you know, we might be at a different place. So if I ever start talking about something like somebody earlier was like, what's the derivative of secant? If you don't know, just say it in the, either ask a question or say it right in the chat and I'll help you out. I'll give a quick review of the product rule. So we're learning the chain rule today. There's a few different rules with derivatives that help us take derivatives of complicated things a little easier. One of them is the product rule. So this is what we use every time you have a product, basically a function times a function. And your teacher is going to initially give it to you as this big, long, complicated thing. So if you're doing f of x times g of x, then you're going to do f prime of x times g of x plus g prime of x times f of x. I know you can not really see that. So it's, yeah. This right here is an f prime of x, then just g of x. This is a g prime of x, and then f of x. Okay. They might have taught you something like, you know, some mnemonic, like the first times the derivative of the second, or the I don't even remember the mnemonic. I think it's the derivative of the second times the first, whatever. They probably taught you some kind of way to memorize it. And whatever your teacher teaches you, and if it makes sense, go with it, okay? But hopefully your teacher will teach you some way to remember it that's a little less complicated than the formula part of it, because that does tend to confuse kids. This is how I do it, so feel free to do it the way I do it if you like it, or the way your teacher does it. I always tend, you just saw, I can't remember the mnemonic to help me anyway, so I'm more of a visual person, so I like to kind of look at it. So I always set up a table, okay? And so in my table, I start by writing my two functions, so f of x times g of x. And then below them, I write their derivatives. So I write f prime of x and g prime of x. And this is just a way to help me organize my information. So I now have the functions and I now have their derivatives. And the product rule actually says f prime of x times g of x. So I'm going to multiply that diagonal. So starting in the low corner up to the top corner, I'm going to multiply those two things together. And then I'm going to put a plus sign in the middle. And then I'm going to multiply the other diagonal. And that makes it so that I don't have to memorize this rule, because I don't like to memorize more than I have to. So I mean, I can tell you the rule, but I don't like to have to remember that, especially when I'm busy doing problems. So by setting this up, I just write my pieces in the box, and then I do my crisscrosses, and I've got my product rule. So let me kind of show you how this would work with h of x equals x squared cosine x, right? So I would set up my box. I'd write my two functions, so it's x squared times cosine x. And then underneath the x squared, I would get a 2x, because that's the derivative of x squared, right? And then the derivative of cosine x is negative sine x. So then to get my derivative, I would do criss, right? 2x cosine x plus cross. Now, obviously, I don't want those signs next to each other, so I'll clean that up. And that's it. That's my product rule. So if you've watched some of the other streams, I know Jamil does it the same way. I'm not sure about the other teachers, but this is kind of a way of keeping track of that information. So if you like it, go ahead and use it. And feel free to share it with your classmates too, because they might like it as well. I find my students do tend to prefer to write it in the box than have to try to remember that formula all the time. So what we're going to do today, since our focus is the chain rule, is we're going to do the product rule and the chain rule together, because why not, right? So here I have cosine of x squared times sine of 2x. So I clearly have a product, right? I have this function times this function. But each of those functions has a chain rule part to it, right? It's a composite function. So I'm going to set up my table. And I'm leaving a little more room on the bottom because I know I'm going to have some work to do in there. But I'm going to write my functions, cosine x squared and sine of 2x. Now I'm going to take their derivatives. So cosine of x squared is a chain rule problem. It's got an outside and it's got an inside. Hopefully at this point, we're going to get past the needing to write outside, inside out every time, because obviously you're not going to write that on your test unless you really want to. But you should be thinking it in your head, right? The outside function is cosine of something. So step number 1 is derivative of the outside. The derivative of the outside is negative sine something. And then we're going to copy the inside. So derivative of the outside, copy the inside, derivative of the inside. So that's the derivative of cosine x squared. I also need to take the derivative of sine 2x. So I'm going to do derivative of the outside. So the outside function is sine of something. The derivative would then be cosine of something. Copy the inside. And then times the derivative of the inside. Just giving you a second to make sure everybody's with me. So I've now set up for my product rule, right? I have my 2 functions, I have my 2 derivatives. So now I can set up my product rule to do my Chris minus or Chris plus cross, or you can say f prime of x times g of x, which is this one. So I'm going to clean it up a little bit as I go here. So f prime of x equals negative 2x, and then you have sine of x squared times sine of 2x. And then plus, right? So product rule has a plus my cross. So plus 2 cosine x squared cosine 2x. Make that a little neater for you. So that's it. That's the chain rule and the product rule put together. So we certainly can use that. Okay. So here's another one. I now have another product with another chain. So I'm going to give you a minute to try to kind of work through this one a little bit on your own. So we have our product here, 2 functions, and they both have chain rules involved in them. So I'm going to shut my screen off for another second and give you a minute or so to see how far you can get with this one on your own. All right, let's see where you are. So I've written down my two functions here. Now I need to take their derivatives. So we've got the chain rule. So the outside of my first one is something to the fourth power. So if I took the derivative of that, I would get 4 times something to the third power. Copy the inside, 4x squared plus 3. And then take the derivative of the inside. So I now have 4x squared plus 3, the derivative of that. 4x squared, take the 2 down, you get 8x to the first. The derivative of a constant, 3, is just 0. So that's my derivative of that one. We'll clean that up as we write our final answer. Okay, the derivative of the other side, right? We have 2x to the third plus 1 squared, same idea. Derivative of the outside function, outside is something squared. So I would get 2 times something as my derivative. My inside would become 2x to the third plus 1. And then we'd want to do times the derivative of the inside. So 2x to the third becomes 6x squared. The plus 1 is just plus 0. So those are our two derivatives. So now we want to do the product rule part. We'll do our Chris first. So I'm going to clean that up as I go. I've got a 4 and an 8x. So that gets me 32x times 4x squared plus 3 to the third times 2x to the third plus 1 squared. And plus, I'm going to do our cross. I got 12x squared see what I did there. And then I have 4x squared plus 3 to the fourth and 2x cubed plus 1. So there we go. There is our derivative of this product with the chain. So as you can see, we went from 1 steps where it was 1 step to now we've learned product and chain, and you probably know quotient too. And I can get some pretty complicated derivatives now. I mean, that was complicated. It's got lots of parts. We did ones with trig that had lots of parts. If you know your exponentials and your logs, you can use those too. I didn't do any of those because I know some schools save those for later, so we'll do that at a different time. But you basically, any 1 step you have, you now can turn into this craziness because you can do products, quotients, and chains, right? So that gets you a lot of opportunities. We can do quotient rule too. I'm going to give you a quick review of the quotient rule in case you need that. So the quotient rule starts out very similar to the product rule. We take the derivative of the first times the second minus, this time instead of plus. So product rule is plus, quotient rule is minus. The derivative of the second times the first. The only real weird difference is that you're going to divide by the original denominator squared. So that second function squared. But you can actually set it up with the same chart. So again, the reason I like that table is because it works and I don't have to think about the rule, and it works for quotients too. So we set it up the same way, right? F of x, g of x, f prime of x goes down here, g prime of x goes down here. Now the only thing is it's a minus. So we do Chris minus cross. And then I wish I had a good trick to help you remember the denominator squared. I don't. You just kind of have to remember it. It's the thing that the most students forget, right? They do all of the hard stuff and then they forget the denominator squared because they spent all this time doing the top. But you just kind of have to try not to forget, right? Do your best. So just to do this problem quickly, because I want to get to the chain rule problem, we got secant x here. We got x squared plus 1 here. We take the derivatives, they're both one steps. So here we get secant x tangent x. Here we get 2x plus 0. So we do Chris. And then this time it's minus cross. And that's our derivative with the denominator squared. Lots of times I actually tell my students to put it there first. Look at, I just almost forgot it, okay? And you do, because you do all that work in the top that you forget that you're even doing quotient rule. So sometimes I often give the suggestion, write it down first, right? Write the denominator squared down first, and then start worrying about everything else so that you don't forget. So that's a good tip too. All right, so let's do a chain rule one. We should have time for at least one, maybe two. We'll see how it goes. So f prime of x, if f of x equals tangent of 4x to the third time over 2x minus 1 squared. So I'm going to take my own advice here, and I'm going to start by taking that original denominator and squaring it so that I don't forget it later. Okay, so that part's done. Now I'm going to find my two derivatives. It's really hard to read. So I'm going to take my derivatives. For my first function, I've got tangent of 4x to the third. So I want the outside function, which is tan of something. The derivative of tan of something is secant squared something. Plug in the inside. Now we're going to take times the derivative of the inside. So 3 comes down to the 4, and we get 12x. 3 minus 1 is 2. For the other one, the outside is something squared. So we're going to take that 2 down times something to the first and copy the inside. So now I certainly did not make that line long enough, but we're going to do our work. So we're going to do Chris. So we're going to start in that lower column and multiply by the top column. So we get 12x squared, 2x minus 1 squared, secant squared of 4x to the third, minus, and we have 2 times 2x minus 1 times tangent of 4x to the third. So hopefully you're kind of getting the handle of all these rules. They take some practice, right? But just kind of take one step at a time. The hardest part about anything in calculus is actually usually not the calculus, it's the algebra. We make silly mistakes, we multiply things wrong, we combine things wrong. Those are where our mistakes happen. So if we just take our time and we are careful about following the steps and the procedures, it works out to be something that's a little bit more manageable. Even though that's a long, complicated answer, we can definitely get it. And that one we actually already did, so we don't have to do that again. All right, so that's actually what I have for you. We could do another quotient one, but I think it's almost 9 o'clock. So I'm going to give you a minute. If you have any last questions that you want to ask, you can type them up either and ask a question or in the chat, and I'll answer those for you. So think about that real quick. You also, please join us on social media, right? So we're at Think Fiveable, and you can follow us on Twitter, Instagram, or YouTube. And share this with your friends because you never know. Sometimes it's nice to get somebody different's perspective, and it gives you some new ideas to share with your teachers. And there's actually ones to help teachers too, so you can let your teachers know if they don't already about this program as well. So if you don't have any questions, I'll hang out here for another minute or two in case you do. But otherwise, it was great working with you guys, and I really appreciate you coming out tonight. So thank you. You guys totally didn't hear any of that because I had my microphone off. But I did just say that somebody did point out that I missed a 2 right here. We did the derivative of the outside, we copied the inside, and then we forgot to copy derivative of the write the derivative of the inside. So there is a 2 missing there. And so it changes your answer to, nope, you didn't do something wrong, I did. You'll learn very quickly when you do stuff like this that when you're talking and you're writing, it's very, very easy to make mistakes, just like I'm sure you realize in class too, right? You do all these problems and you make mistakes. So we all do it, teachers too, which is why you shouldn't stress out when you do it because we all do it, right? Your teachers are going to do it. You're going to do it. Obviously, we want to do it less so we don't do it on the AP test. But for sure, don't always think you necessarily did something wrong because there's definitely some spots for little mistakes. And so that was one. So thank you for catching that and letting me know. All right, guys, have a great night. It was awesome working with you, and I will hopefully see you guys again soon.